In October 2017, something entered our solar system that shouldn't exist. It was moving too fast, shaped all wrong, and when scientists tried to figure out what it was, it literally accelerated away from us like it was late for an appointment. A Harvard professor said it might be alien technology. NASA said, hold on, let's not get crazy. And somewhere in between those two positions lies one of the most fascinating cosmic mysteries of our lifetime. This thing was so weird that astronomers had to invent an entirely new category just to classify it. Its name is Oumuamua, Hawaiian for scout or messenger. And folks, this messenger brought questions we still can't answer. By the end of this video, you're going to understand why some of the smartest people on Earth are still arguing about a space rock that visited us 7 years ago, why it might have been traveling through the galaxy for millions of years before photobombing our solar system, and why we desperately need it to come back, except it never will. Buckle up, because this story has more twists than a pretzel factory. Picture this. You're an astronomer in Hawaii, probably drinking overpriced coffee and scanning the night sky like you do every night, when suddenly your telescope picks up something that makes you spit out that coffee all over your keyboard. On October 19, 2017, the Pan-STARRS telescope at the Haleakala Observatory detected an object moving through our solar system, and at first everyone thought, cool, another asteroid, add it to the list of space rocks we've cataloged. But then, someone actually looked at the data and realized this thing was moving way too fast and at a completely wrong angle. It wasn't orbiting the sun like a normal, well-behaved solar system object. No, this rebellious space wanderer was on a hyperbolic trajectory, which is science speak for this thing came from somewhere else and it's just passing through. Suddenly, coffee cups were dropping everywhere because astronomers realized they were looking at the first confirmed interstellar object ever detected passing through our solar system. Not from the asteroid belt, not from the Kuiper belt, from actual interstellar space, the vast darkness between stars. The discovery was so significant that the International Astronomical Union had to create a completely new designation system. They couldn't call it a comet or an asteroid because it was neither. They called it 1I 2017 U1, where the I stands for interstellar, and they gave it the name Oumuamua, which roughly translates to a messenger from afar arriving first, because apparently Hawaiian astronomers are also poets. But here's where things get spicy. By the time we realized what we were looking at, Oumuamua had already made its closest approach to the sun and was heading back out into the cosmic void. We had missed our chance to get a really good look at it. Imagine finding out your house was visited by an alien tourist, but you only noticed the footprints after they'd already left the planet. That's essentially what happened, and astronomers were collectively kicking themselves for not being ready. Now, if you're thinking Oumuamua looked like a normal space rock, let me stop you right there, because this thing was absolutely bonkers. Based on how its brightness changed as it tumbled through space, scientists calculated that Oumuamua was either shaped like a giant cosmic cigar or, and this is somehow weirder, like a cosmic pancake. We're talking about an aspect ratio of at least 10:1, meaning if it was a cigar, it was roughly 400 meters long, but only about 40 meters wide. To put that in perspective, that's like if someone took the Empire State Building, laid it on its side, and then compressed it until it was as wide as a 4-lane highway. Nothing in our solar system looks like this. Our asteroids are generally lumpy potatoes, our comets are dirty snowballs, but Oumuamua looked like someone's failed attempt at rolling a space burrito. The tumbling motion was equally bizarre. This thing was rotating along multiple axes, spinning end over end like a football thrown by someone who never learned how to throw a football. Every 7.3 hours, it would complete a rotation, and its brightness would vary by a factor of 10, suggesting it was either extremely elongated or extremely flat. Some scientists proposed it might look like a pancake or even a disc, which let's be honest, doesn't make things less weird, it just trades one flavor of weird for another. And here's the kicker. We never got a direct image of it. Every conclusion about its shape comes from analyzing the light it reflected as it spun through space. It's like trying to figure out what your neighbor looks like by watching their shadow on a curtain. Could be accurate, could be wildly wrong, but it's all we've got. The shape alone was enough to make Oumuamua the talk of every astronomy conference, but wait, there's more. And it gets weirder. All right, here's where Oumuamua went from "that's unusual" to "somebody call Mulder and Scully" territory. As astronomers tracked it leaving our solar system, they noticed something that made absolutely no sense. It was accelerating, not slowing down, which is what you'd expect from an object moving away from the sun's gravity. Accelerating, speeding up, like it hit the gas pedal on the cosmic highway. Now, before you think, well, obviously it was aliens, there's a perfectly normal explanation for this kind of behavior. Comets do this all the time through something called outgassing. When a comet gets close to the sun, the ice on its surface heats up, turns into gas, and shoots out into space, creating that classic comet tail we all know and love. That escaping gas acts like a tiny rocket engine, giving the comet a little push. Problem solved, right? Wrong. So very wrong. Because Oumuamua showed no visible tail, no coma, which is the fuzzy cloud of gas and dust that surrounds an active comet. No outgassing that anyone could detect with any of our instruments. It was just a dark, silent object accelerating away from us like it had somewhere important to be. Scientists were pulling their hair out because objects don't just accelerate in space without a visible reason. Physics doesn't work that way. You need a force, and forces leave evidence. But Oumuamua was apparently playing by its own rules, possibly rules written in an alien language, or possibly rules we just didn't understand yet. The acceleration wasn't huge, mind you. We're talking about a tiny deviation from what pure gravitational physics would predict. But in astronomy, tiny, unexplained deviations are how you discover new phenomena, or, if you're lucky, something absolutely revolutionary. And boy, did people have theories about what might be causing this acceleration. Some were sensible, some were wild, and one was so controversial it made international headlines and turned one Harvard professor into either a visionary or the most mocked man in astronomy, depending on who you ask. Enter Avi Loeb, chairman of Harvard's astronomy department, a man with more credentials than a spy in a Jason Bourne movie, and someone who apparently woke up one day and decided to become the most controversial figure in modern astronomy. In 2018, Loeb and his colleague Shmoo Bialy published a paper that asked a simple question: what if Oumuamua was artificial? What if it was, and I'm not making this up, an alien light sail? A light sail, for those who don't spend their weekends reading science fiction, is basically a giant ultra-thin sheet of reflective material that gets pushed along by radiation pressure from starlight. Kind of like how a sailboat uses wind, except the wind is photons from the sun. It's not a crazy concept. Humans have actually designed light sails and even launched a few into space. But Loeb suggested that Oumuamua's weird shape, its unusual brightness, and especially its mysterious acceleration could all be explained if it was a thin, artificial stretcher built by an alien civilization, possibly a piece of space debris from an ancient probe, or maybe even a functioning light sail that was still doing its job after who knows how many millions of years. The academic world absolutely exploded. Some scientists called it irresponsible speculation. Others said it was publicity-seeking nonsense. A few quietly admitted that, while unlikely, it wasn't technically impossible, and someone needed to consider all hypotheses. The media had an absolute field day because Harvard scientist says Oumuamua might be aliens is a way better headline than anomalous interstellar object displays non-gravitational acceleration consistent with cometary outgassing but lacking visual confirmation. Loeb doubled down, wrote a whole book about it, and basically said, look, I'm not saying it's definitely aliens, I'm just saying we should be brave enough to consider it as one possibility among many, and the fact that everyone is so uncomfortable with this conversation says more about scientific culture than it does about Oumuamua. Whether you think he's a courageous scientist willing to think outside the box, or a tenured professor who went off the deep end, you have to admit, the alien hypothesis made everyone pay attention. And in science, attention means funding, and funding means we might actually be ready for the next Oumuamua when it shows up. But of course, there's another explanation, one that's almost as weird but doesn't require invoking extraterrestrial civilizations. And honestly, it might be the correct one. So what if I told you that Oumuamua might be accelerating because it's farting invisible hydrogen? Stay with me here, because this theory is both hilarious and scientifically brilliant. In 2023, researchers Daryl Seligman and Jennifer Bergner proposed what they call the dark comet hypothesis. And it goes like this. Imagine Oumuamua formed in a molecular cloud somewhere in the galaxy, a place so cold that hydrogen molecules got trapped inside water ice, kind of like fizz in a soda bottle. As Oumuamua traveled through interstellar space for millions of years, it got absolutely bombarded by cosmic rays, which are basically tiny atomic bullets flying through space at near light speed. These cosmic rays smashed into the ice and freed up hydrogen molecules, which then got stored inside the ice matrix like a cosmic battery. When Oumuamua finally swooped close to our sun, that ice warmed up just enough to release the trapped hydrogen gas. But here's the clever bit. Hydrogen is incredibly hard to detect. It doesn't reflect light well, it doesn't create a visible tail like dust or water vapor, and it's nearly transparent. So Oumuamua could have been outgassing like crazy, pushing itself along with escaping hydrogen jets, and we would never have seen it. It would look exactly like a dark, silent object mysteriously accelerating for no visible reason, which is exactly what we observed. The dark comet theory gained serious credibility when astronomers discovered similar behavior in some small, near-Earth objects. These objects also showed tiny, unexplained accelerations without visible comet activity, suggesting this might be a whole class of objects we didn't know about. It's like finding out that some cars run on invisible fuel, and we've just been confused this whole time about why they keep moving without gas stations. The beauty of the dark comet theory is that it explains everything without requiring alien technology, but it's still exotic enough to be fascinating. Oumuamua wouldn't be a comet in the traditional sense, but it wouldn't be an asteroid either. It would be this hybrid thing, a frozen artifact from the space between stars, carrying trapped gases from its birth cloud and releasing them in ways we can barely detect. Is it as exciting as aliens? Debatable. Is it probably correct? Yeah, probably. But here's the thing. We'll never know for sure because Oumuamua is gone and it's not coming back. Trying to trace Oumuamua's origin is like trying to figure out which specific raindrop in a storm hit your windshield 3 years ago while you were driving. Scientists attempted to work backward from its trajectory, and the best guess is that it might have originated from somewhere in the general direction of Vega, a bright star about 81 light-years away. But here's the problem. Vega wasn't in that position 81 light-years worth of travel time ago. Stars move, Oumuamua moves. Everything in the galaxy is orbiting the galactic center in this massive cosmic dance. And after millions of years, pinpointing exactly where something came from is nearly impossible. It could have been ejected from a young planetary system during formation, when giant planets were playing cosmic billiards with smaller objects. It could have been knocked loose from its home system by a close encounter with another star. It could have been wandering the galaxy since before Earth even existed, a lonely traveler that happened to pass through our neighborhood just in time for us to invent telescopes good enough to spot it. As for where it's going, the answer is away. Just away. It's currently beyond Neptune's orbit, moving at about 26 kilometers per second relative to the Sun, and it will eventually leave our solar system entirely and head back out into interstellar space. In about 20,000 years, it'll be closer to another star than to our Sun. Eventually, it'll get gravitationally nudged by other stars. Its path will change, and it'll continue this cosmic wandering until the universe ends or it smashes into something. It's kind of poetic, really. We gave it a name, we argued about what it was, we wrote hundreds of papers about it, and it just kept going, completely indifferent to our fascination. So, where does this leave us? Well, the good news is that astronomers are now absolutely obsessed with finding the next Oumuamua, and we're getting better at it. The Vera C. Rubin Observatory, which is about to come online, will scan the entire visible sky every few nights and is expected to detect dozens, maybe hundreds of interstellar objects over the next decade. ESA's Comet Interceptor mission is literally designed to sit in space and wait for an interesting interstellar visitor to show up so it can chase it down and actually get close-up data. Japan's Hayabusa 2 probe, which already successfully returned samples from an asteroid, is being redirected to fly by asteroid 1998 KY26, giving us practice for intercepting fast-moving objects. We're basically preparing for the next cosmic mystery to show up, and this time we'll be ready. We'll have better telescopes, faster response times, and maybe, just maybe, we'll finally answer the question, what the hell was Oumuamua? But here's the thing, and this is what keeps me up at night. What if Oumuamua wasn't special? What if interstellar objects pass through our solar system all the time and we've just been missing them? What if there are weird things flying past us constantly, dark comets and rogue planets and who knows what else, and we're only now developing the eyes to see them? That's both terrifying and exciting, which honestly describes most of astronomy. If you enjoyed this deep dive into one of the weirdest objects ever detected, smash that subscribe button because we're going to keep exploring these cosmic mysteries together. And trust me, the universe has plenty more weird stuff to throw at us. And here's my question for you. Do you think Oumuamua was a natural object, like a dark comet? Or is there a chance, however small, that Avi Loeb was onto something with the alien hypothesis? Drop your thoughts in the comments because I genuinely want to know where everyone stands on this. Thanks for watching, and remember, the truth is out there. We just need better telescopes to find it.